Hello everyone. Last class we have discussed about closed loop system of machines and we have gone through current limit control. Today I will discuss about torque control and speed control of machines. Here we will see that to get desired torque of the motor or to get desired speed of the motor, closed loop system is to be developed. And the function of the closed loop system is to process the error between the desired and the actual one through a controller, and ultimately controller will develop switching pulses which will be fed to power electronics converter and then to motor. Let's see those things. So closed loop torque control. Here you can see there is a torque controller, converter, motor, load and a torque sensor. T star is the reference torque or the desired torque. T is the actual torque which is obtained from the torque sensor. So if actual torque becomes equal to the desired torque, then the error becomes 0. That means desired torque is achieved. Now whenever T is more or less than T star, then some error will be there. Now this error will be processed through this torque controller and switching pulses are generated, and those switching pulses will be fed to this converter and then the converter output is fed to the motor. This process will continue till T is equal to T star. Once it is achieved, that means desired torque is obtained. Now this scheme is required in battery operated vehicles, rail cars and electrical trains. Driver presses the accelerator to set the torque reference T star. So as per the requirement of the speed, driver will set this T star, and through closed loop control of torque, the actual motor torque T follows T star. A speed feedback loop is present through the driver. By putting appropriate pressure on the accelerator, driver adjusts the speed depending on the traffic, road condition, his liking, car condition and speed limit. So this controller will generate pulses to obtain this T star. Now let's see speed control. Here we can see there are two loops. This is your inner control loop and this is your outer control loop. The function of this inner control loop is to limit the current within safe limit, and this outside control loop is to obtain the desired speed omega m star. Just like earlier closed loop system, here also it will follow the same thing. Omega m star is the desired speed, the speed we want. Omega m is the actual speed. Now there will be some error. Now if omega m star is not equal to omega m, then there will be some error, and that error is del omega m. Now if omega m star is more than omega m, then positive error will be there, and now this positive error will be processed through this speed controller, and then speed controller output is fed to current limiter. Now this current limiter is set in such a way that a small amount of error can saturate this current. So this current limiter will set a reference value I star. Now this inner loop will try to achieve this I star, and I is the actual current flowing through the motor. So with the help of this current sensor, actual current is sensed and it is fed to this subtractor. So reference current and the actual current is subtracted and net error is fed to this current controller. Now this current controller will generate switching pulses for this converter and fed to the motor. So this inner current loop is there to limit the current within safe limit, so that current should not increase more than the rating of this converter or the motor winding. Now this reference current is maximum allowable current flowing through this converter. More than this it is not possible to allow. Now this error may be positive or negative. Positive error means we have to accelerate the motor. Negative error means we have to brake the motor. In both the cases, whenever desired speed or close to desired speed is achieved, this controller will desaturate and the motor will run at constant speed. Or you can say the equilibrium point is achieved when load torque is equal to motor torque. It implies an inner current loop within an outer speed loop. Inner current loop is provided to limit the converter and motor current or motor torque below a safe limit. The current may be controlled directly or indirectly. For example, in a variable frequency induction motor drives that I will discuss at the time of induction motor drives, the current is controlled by controlling the slip. An increase in reference speed omega m star produces a positive error del omega. Speed error is processed through a speed controller and applied to a current limiter, which saturate even for a small speed error. For a small speed error, this will saturate and I star, that is maximum available current, is set as the reference. Consequently, limiter sets current reference for inner current loop at a value corresponding to the maximum available current. When close to the desired speed, limiter desaturates. Steady state is reached at the desired speed and at current for which the motor torque is equal to the load torque. Now let's see if the reference speed is less than the actual speed. That means braking mode of operation we are going to discuss. So, and decrease in reference speed omega m star produces a negative error del omega m. Speed error is processed through a speed controller and applied to a, just like acceleration, it is applied to a current limiter, which saturate even for a small speed error. Consequently, limiter sets current reference for inner current loop at a value corresponding to the maximum allowable current. Drive decelerates in braking mode at the maximum allowable current. When close to the desired speed, current limiter decelerates. The operation is transferred from braking to motoring mode. That means when the desired speed is obtained, then there is no need of this controller, and motor will run in motoring mode. And the operating point is now shifted from braking mode to motoring mode. That means speed is now achieved. Now continuous supply is required to run that motor at that speed. Drive then settles at a desired speed at a current for which motor torque equals load torque. So at every point after distortion or you can say disturbance or any change in the reference speed, ultimately load torque must be equal to the motor torque to attain equilibrium condition, and the motor will run at constant speed and the operating point will be shifted at that point. So today we have discussed about a few more closed loop system like torque closed loop system, then speed control system. In speed control system, inner current control loop also we have seen. So as discussed earlier, there may be many number of closed loop system based on the requirement of the application. But with the increase in number of closed loops, complexity of the system increases. This should be kept in mind. Thank you.